Hey friends! Today we're going to deeply understand one of the most important foundations in electrical engineering, Ohm's law. It's the key to knowing how voltage, current, and resistance work together. We'll break it down in the simplest way with real-life examples so that you'll never forget it. Let's dive in. Electricity is the flow of electrons through a conductor, just like water flows through a pipe. For this flow to happen, you need a push. This is called voltage. The amount of flow is called current, and the opposition to this flow is called resistance. Understanding the relationship between these three basic electrical quantities, voltage, current, and resistance, is essential in every electrical system. This relationship is defined by a fundamental rule known as Ohm's law. Let's travel back to 1827, to a small lab in Germany. Meet Georg Simon Ohm, a schoolteacher and scientist who loved tinkering with electricity. Scientists were experimenting with batteries and wires, but they couldn't predict how electricity flowed. Ohm noticed that some wires let more electricity through, while others slowed it down. He thought, there's gotta be a pattern here. So, he started testing different wires, batteries, and circuits, measuring how much current, the flow of electricity, came out when he applied a voltage, the push. Through careful experimentation, he observed that the current flowing through a conductor is directly proportional to the voltage applied across it, and inversely proportional to the resistance in the circuit. Thus Ohm's law was discovered in 1827. His work laid the foundation for the modern understanding of electricity, and his law is now a basic rule in electrical engineering, electronics, and physics classrooms around the world. The law is expressed in the simple formula V equals I times R, where V is voltage, in volts, I is current, in amperes, and R is resistance, in ohms. If you know any two values, you can calculate the third. This formula also gives rise to other versions. I equals V/R and R equals V/I. To make it easy to remember, people use the Ohm's triangle, where V is at the top, and I and R are at the bottom corners. Cover the value you want to find, and do the calculation with the other two. To make things clearer, imagine electricity as water flowing through a pipe. The voltage is like the water pressure, current is the flow of water, and resistance is like the width of the pipe. More pressure means more water flow, but a narrow pipe restricts the flow. Similarly, more voltage pushes more current, but more resistance limits it. This is a great way to visualize Ohm's law in a way that sticks in your mind. Let's take a few simple real-life examples. Suppose a 12-volt battery is connected to a 6-ohm resistor. Using Ohm's law, I equals V/R equals 12/6 equals 2A. That means 2 amperes of current will flow. In another case, if you want only 1 ampere of current to flow from a 10-volt supply, you'll need a 10-ohm resistor. These easy calculations show how engineers and electricians decide what components to use in a circuit. Ohm's law is everywhere around us, in phone chargers, LEDs, televisions, fans, and even in the circuits inside a remote control. For example, when you plug in your mobile charger, the internal circuit controls the current and voltage so your phone charges safely. Even small components like LEDs need correct resistors, or they might burn out. A simple 330 ohm resistor can protect an LED when connected to a 9-volt battery, proving how useful Ohm's law is in daily electronics. In electrical design, resistance is very important. If the resistance is too low, the current may become too high, overheating the circuit and causing damage. If the resistance is too high, devices may not work because not enough current flows. That's why designers calculate the correct resistance values using Ohm's law to ensure everything runs safely and efficiently. For those who want to feel the law practically, here's a simple experiment. Take a 9V battery, a few resistors, like 220 ohms, 470 ohms, and 1k omega, and an LED. Try connecting different resistors and notice how the brightness of the LED changes. The higher the resistance, the dimmer the LED, because less current is flowing. This hands-on activity locks the concept of Ohm's law into your brain forever. Another important thing connected to Ohm's law is power. Power is the rate at which electrical energy is used. The formula is P equals V times I. Using Ohm's law, you can also write it as P equals I superscript 2 times R or P equals V superscript 2/R. These formulas help calculate how much power a device consumes, which is especially useful in designing electrical systems or choosing the right components for safe usage. To wrap it up, Ohm's law is one of the most important principles in electrical engineering. It was invented by Georg Simon Ohm in 1827 to explain the relationship between voltage, current, and resistance. It helps us calculate, design, and understand how electrical circuits work, from a simple flashlight to complex machines. The best way to learn it is to practice small examples and use visual tricks like the Ohm's triangle. Once you understand it, you'll never forget it, and you'll see how it applies to every circuit you build or use. Big thanks to you, our subscribers, for making this electrical series so fun. Let's keep learning together. If you loved this, check out our transformer shorts on coils, bushings, and more, or our electrical laws series like Kirchhoff's laws. Hit that like, subscribe, and bell icon to never miss a spark. Drop a comment. Have you used Ohm's law in a project? See you in the next video, where we'll dive into another electrical adventure. Stay powered up.